Friends, so today we'll be learning about a very important algorithm in the computational geometry, which is Cyrus Beck line clipping algorithm. So let's see the parametric equation of a line first, which is given by the line segment is given by joining 2 points A and B. So the parametric equation is A plus B minus A multiplied by T, where T belongs to 0 to 1. So T can range between 0 to 1. So as we can see, if we put T is equal to 1, this becomes A plus B minus A, which is equal to B. That is, we reach the last point on the line segment. And if we put T is equal to 0, this becomes A. That is, we reach the first point on the line segment. And if we put T as a fraction between 0 to 1, we get A and a fraction of B minus A. That is, we reach somewhere in the middle of this line segment. So this is the parametric equation of the line. Now we evaluate IQ. This function we evaluate. So let's say this is an edge of a polygon, and this is the outside area and this is the inside area, and this is the normal which is towards the inside area. So let's say the normal vector, and it's a unit vector, so we can say it's as n cap also. So let's define IQ is equal to Q minus P, where Q is any point about which we want to find whether it lies inside the polygon or outside the polygon, and P is the point on the edge from where the normal is drawn. So IQ is equal to Q minus P dot product with n cap. So this vector dot product with this vector, and because this angle is acute here, the dot product will be positive in this case, because dot product of two vectors is positive if the angle between them is acute. So if the positive, then Q lies inside, as we can see in this scene, inside half space of line, that is inside this plane. And if it is less than 0, then it lies outside the polygon, and if it is equal to 0, it is lying on the edge. Let's see, we should see the trivial cases first. So let's say there is a line segment given by AB, and this is the polygon's edge, and this is the n cap, and IA and IB are both positive because this angle is also acute, this is also acute. So both of them lie inside the polygon in this case. That is, the whole line segment is lying inside the polygon line segment here, okay. And if both of them are less than 0, then a trivial reject case occurs. That is, whole line is outside the polygon, as you can see here, because both of the angles are obtuse. Okay. So let's see the next thing now. Now the non-trivial case, which is of course the interesting one. So out of A and B, one of the point lies outside the polygon and one of the point lies inside the polygon. Okay. So this LT is given by same equation, and IQ is still the same, Q minus P dot n, and any point on the line AB is given by the same equation. So in this line segment AB, any point is given by this, where T belongs to 0 to 1. T can range from 0 to 1. And here we have one more thing, H minus P, because H is on this line. Let's say for a value of the parameter T as, let's say, T only, or let's say T naught or T1, anything. So ph dot n will be 0 because they are perpendicular vectors. We substitute in this equation the value of h. So a plus b minus at, which finally gives us the value of t as a minus p dot n cap upon a minus b dot n cap, which we can write as a minus p dot n cap upon a minus p dot n cap minus b minus p dot n cap. So this is the value of t for which the for the point h, and finally we can get the clipped line as HB. So this is the clipped line which lies inside the polygon. Okay, so this was a simple line. Now let's come to a polygon. We consider a simple rectangle and a line segment AB. In the above case, we observe that all four edges of this rectangle give us different values of t. So this AB can be clipped by all the four edges, giving us values t1, t2, t3, t4. So which t to take in this case? So let's classify our t's in two categories. One is entering and one is leaving. So on this t, AB is entering the polygon, and on this t, AB is leaving the polygon if we consider AB as directed from A to B. Okay, so this is our t's equation for t as we derived above here, and let's call d is equal to b minus a dot n cap. If d is greater than 0, we label t as te, else label as tl, leaving. Why so? Let's consider the entering case first. In this case, AB vector dot n cap, n1 cap is greater than 0. So b minus a dot n cap is greater than 0, which is our d. So in entering case, it will be greater than 0 because it forms an acute angle. And in the leaving case, n2 cap and b minus a vector form an obtuse angle. Hence, b minus a dot n2 cap will be less than 0. So that's all for today. We will consider the other things in the second part of the lecture. Thank you, friends.